Good afternoon. My name is Shimeeka Stanley, and I'll be presenting my project, which is Management of Sensor Networks. And my mentors are Lee Tergeson and Amalai Oyaki. So for my introduction, if you weren't aware, NASA is known for using point-to-point or single relay links to communicate with spacecrafts in space. With more complex missions, with the potential for disruption, the Solar System Internet, which is the SSI, was developed like terrestrial internet, involving multiple hops via relay, spacecraft, and other intermediate nodes. So normally when there is a disconnection, data packets are discarded, but by using DTN, it can assure safe delivery by storing the bundles and waiting until there is a next path of communication that is open. So the objectives of this study is to formulate a solution to the data collection problem. And to do this, we will use the features DTN provides and its protocols on the sensor network. But to monitor and control the network, we will be using the YAML's toolkit. The YAML's toolkit is basically a Python-based software that is used within JPL. These sensors will communicate and send messages back and forth. So this is the sensor network. And say, for example, the control center will send messages to a node, and each node will re-forward the message, and they can send the messages back and forth within each other until they reach the desired destination. So yeah, basically passing the messages back and forth, this will show how sensors work with DTN and the AMOS instrument toolkit. So for the hypothesis, we hypothesize that we will achieve the stormford mechanism that DTN provides by using the AMOS toolkit and the DTN protocol to replicate the SSI. So for our methods, as stated before, we use the DTN protocols and the JPL implementation of these protocols that also includes the AMS, which is meant to work in isolation. And this is beneficial because the sensors will operate in isolated areas, which is the whole goal of the project, to get these sensors in isolated areas and send messages to the destination. The Raspberry Pis will be used as nodes, and the LoRa's will be sent space packets. Now the JPL protocols collects packets and is controlled by the AIT and the control framework. Sample TCP and UDP test applications will be written in C and Python to send and receive data chunked into arrays. Now, TCP is a connection protocol and UDP is a connectionless protocol. TCP establishes the connection between sender and receiver before the data is sent, but UDP does not establish a connection before sending the data. So this is the application that we used. And it starts with the link, which includes the Ethernet and the radio, and LTP, which includes UDP and TCP and framing, and it's also a link service, and convergence layer, which is BP, and it includes UDP, TCP, and LTP, and the AMS, which I said before, which is included in the JPL implementation, and it is a message layer, and it has UDP, TCP, MSGQ, and BP, which is also shown here too. So for our results, the sample tests for the initial implementation were a success given the setup that we used. As you can see in the image in the left-hand side, this is the Ethernet switch, and it's connected to all the nodes and also the power source and the control center. So the nodes are the Raspberry Pis, and it's connected to the Ethernet switch, and the nodes are also connected to a monitor. So we managed to get the TCP and UDP test applications working in the control environment, and they were modified to send data between each node. When we tested the TCP and UDP by sending simple messages, they received the messages with no packets lost. The developed sensor network successfully transmitted messages on a dual channel in these remote locations when housed in areas 70 to 80 meters away from each other. And during the small scale test, one of our nodes lost power and was unable to transfer data, which includes packet loss, unfortunately, from the previous node. However, due to the store forward mechanism that DTN provides, it continued sending the same sample packet until it was completely received. So this was when we were conducting the test. As you can see, we started sending the simple hello world message, and we stopped when we determined the range or how far the messages can be sent. And for the results of our study, we did not get the distance that we wanted for the project, so we decided to construct a monopole antenna with ground plane radials. As seen in the image in the right hand side, the monopole antenna included a vertical element, 4 quarter wave radials, which are here in the orange, and the feeder. Now, the coaxial cable was fed through the feeder, but the coaxial cable is also connected to the radio. So, by making the monopole antenna, it increased the range of each node to about 500 to 700 meters, and this extended the communication range of the normal LoRa radio that we used in the first place. So we managed to make the LoRa and the antenna compatible, and they worked well together. So in conclusion, we got the DTN protocols and the AIT to send messages or send data between the nodes and a control center like SSI. Even though there was interference, the store and forward mechanism of DTN showed that packets can be sent without them being lost, and this shows why DTN is reliable in SSI when compared to IP. So, in comparison with IP, which is right here, and DTN, IP can only send data when there is a complete path, which is like right here. So this complete path must be done without any interference. So as you can see with the first 4, they weren't able to send the data completely, even though there could have been an interference. But with DTN, there can be interferences, and the data will still be kept and delivered safely due to the store and forward mechanism that it uses. So in the future, we plan to conduct a larger scale test where we will have enough power and a stronger antenna to prevent packet loss. For the LoRa hats, we will determine if the antenna radiation pattern is suitable to create good signal to noise ratio. We will also increase the number of nodes to test the network's range reliability, redundancy, and flexible data transfer. And that's it for our presentation. Thank you for having me.